Hello and welcome back to Internet of Terms. This episode is called Put It to the Test. I'm Royi from Samsung's Global Innovation Center in Tel-Aviv, where we help software and service startups succeed with funding, mentorship, office space, access to Samsung, and much more. If that interests you, please email me at royibwy@gmail.com. So, what do we desire today? Well, we want to improve quality as well as stability while making the feedback loops shorter and save time and money on costly QA cycles. Wait, more quality for less money? You might be seriously questioning where I'm going with this, but the answer is quite obvious, and it is to automate everything and to move towards a continuous delivery approach, since it will reduce the QA overhead in time and in the need of large number of manual testers, which saves money, so you could release more iterations to shorten feedback loops while keeping it stable. Like development has been doing for the last 10 years. And I know what you're thinking about. That Android has a problem with doing that because of backward compatibility. Well, not anymore. The test support library supports all the way back to Froyo. With what, you ask? Excellent question. Ready to get started? The testing support library, which I'll refer to as TSL from now on, contains all you need for Android QA automation, starting from the Android JUnit runner, which is a unit testing framework for Android, which means it tests code functionality. It replaces the old fragmented instrumentation test runner, supports the newer JUnit 4 along with the old JUnit 3, and is in charge of the test lifecycle, i.e., loading the test to a device, running it, and returning a full report to your IDE. It also allows you to access valuable instrumentation information like the test progress, the target and test app contexts, and the command line arguments that you can dynamically change. It allows you to filter tests by test device API, device type, i.e. virtual versus real, and test size, which means unit, feature, integration, sanity, and regression. It also allows you to use sharding, which means you can run any subset of the test on any test suite. After we tested functionality, let's move to the UI. Espresso is a white box UI test framework, which means the tests are aware of the target app's code, and the tests revolve around the UI's behavior rather than the code functionality. It has really cool features like finding the view by calling it from the Android's own r.id by strings. It also handles adapters, and it realizes that unlike other views, they are only useful after the event of data population, so it intercepts that data with onData, which is a method. And it provides a reference to the user action inside the adapter. It also allows you to perform all the UI actions you would do manually, like clicking, swiping, key and button pressing, and text typing, as well as opening links. Now the crown piece. Espresso has a built-in thread sync system, which is deterministic. What does that mean? It knows when the async thread is finished and then continues the test. No more using wait or sleep and get mad when a test fails because of milliseconds rather than actual issues. The last piece of the puzzle is the UI Automator, which is the black box UI testing, meaning that you can run it on any app, not even yours. Since it is unaware of the app's code, it just moves around on the screen as a user will do. And it can perform actions such as using system actions such as the home button, or handle collections such as adapters, perform selections, clicks, and presses, and gather the visible information on the object which are displayed on the screen. Go ahead, run a test on Gmail. It's fun. Okay, we're done. Go and try it. It will change your life. And if you miss my strange bug image, here you go. Happy? Good. Since we're all out of time, please join us next week for another installment of Internet of Terms. Please look at the description to find links to all the posts, articles, and repos I used. Bye-bye.